So this video is on problem number 3 in your recitation class. So basically, I'll change the numbers, of course, right? So we're given that, we're told, right, that you're told a frequency of some wave, right, is given by, let's make it up as 42.3 hertz. You're also shown a graph of the problem, and let's see if I can draw it properly. Good enough. Okay, good. And we're also told the height distance from here to here, and I'll make it up. Let's make it as 2.5 meters. Okay, so, and we're also told that the distance from, so from here, I assume this is the crest of the wave to the trough. So the distance from the crest to the trough is given by, let's make it up, 1.72 meters. Made that up. Okay, so crest to trough. And part A is asking, okay, so we have a frequency, we have an amplitude of wave, and then we're asked to find the amplitude. So the amplitude is just going to be, so notice from peak to peak, right, from the crest to the trough of the wave, right, is 2.5 meters. So the amplitude is the distance from the center to either the crest or to the trough, backwards, whatever. So that's really, the amplitude is nothing more than, in this case, 2.5 meters divisible by 2. And actually, I just told you not to use units right away, right? So let me do the calculation without the m. And 2.5 divided by 2 is 1.25. But we convert this into the nearest two significant digits. In this case, there's two significant digits here, so this would actually be 1.3 meters. So it's kind of weird, but those are the rules for rounding up or rounding down the number of significant digits. So let's go to part B. Part B, we're asked to find the wavelength. Let's try to find the wavelength. So we actually calculated from crest to the trough. So from the trough to the crest must be exactly the same. So we're expecting that whatever this distance is, we double it to get the wavelength. So in this case, the wavelength, I'm going to use lambda, is going to be 2 times 1.72, and we get an answer of 3.44, right? But remember, 3 significant digits, so we keep the 3 significant digits, so this is 3.4 meters. So the wavelength is given by 3.44 meters. Part C is asking the period. Okay, so C. So if you remember the frequency, right, so we already know what the frequency is, so we know that the frequency is given by 1 over the time period. So we can write this as the time period is 1 over f. So multiply by t and divide by f on the side. So the time period is going to be equal to 1 divisible by 42.3 hertz. And where's my calculator? So 1 divided by 42.3 gives me a value of 0.0236, and there's 4, but there's 3 significant digits, so I'm only going to keep it to 2.36. And I want to do it in terms of powers of 10, so this will be actually written as 2.36 multiplied by 10. So I move this to 2 significant digits, so it's minus 2, and standard units is seconds. So it's 2.36 6 times 10 to the minus 2 seconds. Part D in the problem says the speed of the wave. So if you remember, the speed of the wave, right, is nothing more than lambda times frequency. And lambda happens to be given as 3.44 meters. And the frequency, frequency is 42.3. I'm reading 3.44, yeah, 42.3. These are all standard units, so bring out the calculator. 3 significant digits, so good. 3.44 multiplied by 42.3 gives me a value of 145.5, but remember, 3 significant digits makes it 146. And 1.46, I can change that into standard units, power 10, so 4.6 times 10 squared, and meters per second, because we're always using standard units everywhere. So that's the meter, kilogram, second, hertz, and so on. Okay, and that's the problem number 3.